This conference will now be recorded.
Hello everyone. So today we'll be starting off with Ethernet protocol training and Ethernet MAC design verification project. This will be done over a span of 3 to 4 weeks. This will be done over the complete week. In case you have got a communication that it's also on weekends, I would like to correct that because it is also being targeted for the freshers who are undergoing the training at the institute. Because of that, it will be a full week training. In case you are a working professional and you are not able to attend some of the weekday sessions, we will be providing you with access to the recorded videos of each and every session. So that is as per the institute policy. Every session you attend, you get access to the recorded video of that session for 1 week duration. So that is about the schedule. We will be publishing the schedule. What will be the timings? I mean, mostly these sessions should start around 10:30 every day. This would be close to 5 or 6 days per week. Every session, initially when we are doing protocol training, we'll try to keep the sessions relatively shorter, around 2.5 hours, so that we deliver enough content that you can take in a day. I mean, if we try to overstretch it, you may not be able to take up so many concepts. So we will try to keep it shorter initially. Later, once we move on to the verification aspects, where we study the design features, architecture, and develop the test bench components, there we'll have longer sessions. Now, you are all familiar with, have basic idea about Ethernet and the concept of LAN, and you all know the significance of LAN in today's world. I mean, where everything is interconnected. That is where this project, Ethernet MAC design and verification project, has a lot of significance for all of us. And even many companies who work in networking domain, Ethernet MAC becomes one of the fundamental concepts that you should be aware, so that you can move on to the advanced aspects like TCP IP protocol or IPv4, IPv6, or any other advanced protocol you need to learn. Ethernet MAC is the foundation for all those things. So in today's session and the next following sessions, we will be talking about what is this standards like IEEE 802 standards. What is 802.1, 802.2, 802.3? Like that, there are around 6 standards. What is the significance of those, and where does Ethernet fall into this? And above all, there is something called as OSI model. Then there is something called as ISO. So how these are all interconnected, all those aspects we will be discussing in today's session and the following sessions. So the how training will be organized, what is covered as part of training. Basically, we will be focused on Ethernet protocol, mostly for 10G, 100G speed. Okay, this only focused on this, nothing beyond that. I mean, there will be biggest 10G, yeah, these things, and we will be focusing on Ethernet MAC design verification. Initially, we'll be doing using system Verilog. We will have one or two sessions, few sessions on how to do using system Verilog and UVM. So mostly initial part of the training will be only focused on system Verilog. Later part of the training will convert the same test bench for system Verilog and UVM based test bench environment. So this protocol training might go for initial 1.5 weeks, because whenever we do this kind of design verification projects, the most important part of the design verification is to understand the protocol, understand the design very well. That makes the whole process of verification a lot easier. Now, we will be getting into Ethernet protocol training. Before I go ahead, do you have any questions?
Srinivas just wanted to know, in the weekdays, what will be the timing?
No, actually, is the schedule. Again, my apologies if you got a wrong mail saying that mail communication saying that weekends also training is there, weekends only training is there. That is wrong. The schedule will be more like Monday to Saturday. Most possibly around 10:30 a.m. is the schedule, and it might go till 1 p.m. or it might even stretch based on the what is the depth at which we are talking. I mean, see, the point is I will see what is the right amount of things I can do in a day so that you don't feel exhausted with the amount of content that's being taught. We'll do this. This is the schedule we are planning. Sunday will be off, and if someone is working and they are not able to attend these sessions, we provide the recorded video. Even otherwise, for every session you attend, you get a recorded video access for that, for all the videos, all the sessions.
Srinivas, will you cover the RAL model development also for Connect?
RAL model development you are telling?
Yeah, yes.
Yes, we will cover. When we go to, see, even in SV, we will include register model without using UVM registers, UVM register, without using classes, using SV classes. When we come to UVM register model using
Okay.
using register model development using RAL based classes. That also.
Okay.
Hello, sir.
Now, why is this? Yeah, please tell me.
Yeah, sir, some of us haven't studied UVM yet. So what about us, sir? Means
That
how
would
you are
be not relevant for you. Basically, that part of the training is not relevant for you. Basically, those who are attending the regular part of the training, for them, this is the one. There are some working professionals who want to do it using system Verilog and UVM. For them, these additional sessions are being planned. Otherwise, I would have directly started with SVUVM. That would have been the easiest thing for me, because this will be a kind of double work for me. But to make sure that you are able to cope up, first we'll only do with SV. Then for remaining people, we'll target using SV and UVM.
Okay, sir. And sir, one more question. For this protocol, we will be having practicals, right? Means lab
Yes.
session. Yeah, sir.
Yes.
So along with that lab session, we will be having some AXI protocol, or AXI protocol is done.
AXI protocol is done. See, the point is we can't keep something for 2 months. So we are, as per my knowledge, 3 weeks we started AXI, and AXI 3 weeks is good enough. If someone is saying I need six weeks, then your course will go for 2 years, and we don't have 2 years time to do the course.
But sir, not all of us are getting proper output now.
No, see that at one point you need to get the support. You can always come to me with whatever support you need. You have the videos. You need to check the videos. I mean, what is the effort that takes in checking the video and seeing where you are missing? I'm not. Anyway, we can have a different session where we can discuss all those things. But
Okay.
AXI is okay. If you are not able to go beyond there, I think better you focus on what you have done so far. Because even if you go to interviews, they don't ask you wrap, incrementing, all those things. If you're able to explain the basic thing, that's fine.
Okay, sir.
Yeah. Any other questions?
So Monday to Saturday, all the days we will have theory session, right?
No. It will be theory and labs. See, one day could be a theory session. The next day could be a lab session. Let's say I'm doing some theory topics. On Tuesday, there might be a specific session focused on discussing those concepts, just to make sure that everyone is revising, everyone is able to follow whatever we have been doing. So it will be like alternate things, alternate day theory and labs. That would be more effective when we start off with the test bench development. But initially, it might be more of theory. Initial 1 week. Okay. So now let us talk about what all contents and how the training content will be delivered. What all things will be covered. What all things covered. I think I have already given. So when it comes to Ethernet protocol, what we will do is we'll talk about two things. One is the protocol itself. One is the Ethernet MAC design understanding. Ethernet MAC design understanding. I mean understanding the specification. So we'll talk about Ethernet protocol, then we'll talk about Ethernet MAC design understanding by going through the specification. So once you have gone through it, then we'll go through the regular process of understanding the architecture, developing the verification plan, test plan, implementing the test bench components, integration, developing test cases. All that process we'll go through. So now let us get into the Ethernet protocol. Okay. Time to time, I might be giving some analogies, which is to make the learning easy for you. So I'm not sure how relevant or irrelevant they might be, but I will be. It is just to make sure that you're able to understand the protocol properly. Okay. So to understand Ethernet, we need to understand the need for computer networking, and I'm sure we don't really need to get into the need for computer networking. I mean, we are able to do all this, whatever training is we are doing, whatever work we are doing in the office, everything. It is all happening because some or other place we are all connected to a network, and that is what is enabling us to access the World Wide Web or connect to some servers and execute the jobs or various types of things we are able to do because of the concept of computer networking. Now, what is computer networking? A group of computer systems or any hardware devices interconnected, basically linked together through some communication channel. Now, that communication channel need not be a LAN. It can be anything. It can be a Wi-Fi. It can be a LAN. It can be a Bluetooth. There are multiple ways in which you can do the computer networking. Basically, what does the computer networking do? It facilitates the communication between different systems, and it facilitates the resource sharing. Now, this is where there is a need for something called as OSI model. Let us first understand what is the in this context. There is one in around 1984. One standard was set up. One organization was formed called as ISO. International. What is it? I forgot. Yeah, ISO, International Organization for Standardization, basically. That is was formed. That is International Organization for Standardization was formed. So what is the need for this ISO is, now when we are using let's say in your house, you are connected to the internet and you are using your laptop. If you see that laptop ecosystem, what is all involved in that laptop? One is the laptop itself is involved. One is the Wi-Fi router is involved. One is some LAN cables will be involved. And there will be, see, before it comes to Wi-Fi router, the LAN cable needs to be connected to router. Okay. Sometimes switches will be there. If you come to institute, let's say in your house, there are 6 people who want to connect and they want a wired connection. There will be a switch, 8-port switch will be there. So there are various things that can be there in the what do you say? House laptop ecosystem. I mean, where you are connecting to something and you are using everything. Okay. If you see, this is being manufactured by someone. Let's say Lenovo. Let's say this is being manufactured by, let's say, Netgear. Let's say LAN cable is manufactured by, let's say, D-Link. Different people, different companies are manufacturing different components. Now, if everyone manufactures with their own understanding, their own assumptions, then connecting this laptop to the Wi-Fi router and through the LAN cable might become a challenge for us because everyone is making their own assumptions. What do we need in that case? In that case, what do you think we require?
A common
Someone tell
set
me
of
what
protocol.
basically a common set of guidelines. We require a common set of guidelines which needs to be followed by everyone who develops the components meant for networking, components meant for networking purpose. It's a long statement, but the basic summary is what? A common set of guidelines for any components meant for networking purpose. That is where one organization was developed called as ISO. What does ISO stands for? International Standards, International Organization for Standardization. Okay, or you can read it as International Standards Organization, something. Okay, what did they do is they come up with something called as OSI model, or also called as OSI reference model. I will talk about why it's called as reference model also. I'll talk about what they told is anything you want to do with networking, anything we want to do in networking, anything we want to implement in networking devices should be implemented. It's not must, understand, not must. Okay, it should be is important. Should be implemented as into 7 layers. Those 7 layers are basically at the very top, it is application layer. Then we have presentation layer. Then we have session layer. Then we have transport layer. Then we have network layer. Then we have data link layer and physical layer. So the ISO standard, ISO organization, what they said is you implement everything into these layers. They have also given some guidelines on what should be done in what layer. Like in application layer, what is supposed to be done. In presentation layer, what is supposed to be done. Like that for every layer, they have provided a set of guidelines that need to be followed while implementing these layers. Now it's just a reference. It is just a reference. That means it is not a compulsory thing that everything must be followed exactly. On top of all this, further to this networking concepts were further standardized through IEEE 802. In that there are multiple versions: 802.1, 802.2, 802.3. So can someone tell me which version is Ethernet MAC falls into?
802.3.
802.3 is what Ethernet MAC falls into. Okay, that is the standard which tells how the Ethernet MAC communication should happen. So they provide finer details about how the Ethernet communication will happen, how the packets will be framed, what will be done in the individual layers, everything. This gives a bigger level picture for all these things. The individual standards like 802.3, 802.4, they will further talk about how those things need to be implemented in detail at very basic level. Okay, let's get back to the presentation. Okay, so what is the need for OSI model? Is there are n number means in lot of users who use computer network and are located all over the world. So to ensure national and worldwide data communication systems that can be developed are compatible with each other. See, what is the need for this OSI model? these systems should be compatible with each other. See, there might be hundreds of devices that are being developed, routers, switches, the computer hardware. There are many things that are being developed. So this OSI model gives a guideline on how they should be developed. ISO has developed OSI model. ISO stands for International Organization of Standardization. This is called a model for open system interconnection, OSI, and is normally called as OSI model. So basically, open system interconnection model. Means open means something. I believe open here is referring to there is no what do you call proprietary thing here. It is something anyone can follow this guideline. Next, to understand this, okay, these are the various layers. Just please go through this once. Okay, so that OSI model divides the device functionality into networking related functionality into 7 layers. At the very bottom level is the physical layer, then the data link layer, network layer, transport layer, various aspects of it. As I told, these 7 layers can be further divided into 2 major categories. Things that need to be done at the software level, things that need to be done at the hardware level. So 3 of the layers are software related layers. 3 of the layers are related to the hardware layer. Now the question comes, what is meant by software layer? What is meant by hardware layer? To understand that, let us take one simple analogy. We will take an example of food delivery service. To understand this, let's take the example of a food delivery service. Let's say we are using one of the food delivery service, Swiggy, let's say, to user places an order and gets the item delivered. Let us see what all things goes through that and how that can be correlated to our different layers. There we'll try to understand what is meant by software, what is meant by hardware. If you see at top level what is happening, who are the 2 entities involved in this? Let's say in food delivery, what are the 2 entities involved? One is customer, one is the restaurant. Customer is a node. Basically, going forward, you will see that every system, my laptop is a node. I mean, if I'm talking about networking, computer networking, my laptop is a node. Another laptop is a node. Instead of calling everything as a laptop or a mobile phone, anything, we'll call technically that is called as a node. Customer is a node requesting the data. I mean, he is requesting for the item. Restaurant is the node which is servicing the request. Now you may say, then where is Swiggy involved, or where is that food delivery app is in, that whole company is involved? It is the thing which is facilitating this whole thing to happen. So that is where we will understand where does they come into the picture. Now, if you take up this service, whatever we are talking about, this service requires application at the user end. See, what do? I open the food delivery app. So I'm opening the application. So that is where my application is being started. That is the application layer. I have invoked the application layer. Then we place the order. So that is where it shows me the presentation that these are the items. This is the order I want to place. So I have placed the order. So it gives me a presentation kind of thing. This is the item. This is the order. And you confirm that I want to make this order. That's the presentation, let's say. Then a session gets started on the Swiggy platform. See, this whole thing is starting on their application level. Session gets started on the Swiggy platform. What is session is getting started means it is from the time you have placed the order till the time order gets delivered. There is one session is running on the Swiggy platform. From the time you place the order and from the time it gets delivered and you say that item has been delivered, that session is active. That is what is done by the session layer. One session is getting created. Now, why these sessions are required is because this food delivery platform may have thousands of people placing thousands of orders from thousands of restaurants. All of them are tracked. All those things are tracked using various sessions. So when I place an order, till the time that gets delivered to me, that whole thing is like a one session. Then comes the transport layer. I probably won't be able to correlate exactly because see, don't think that this is exactly Ethernet LAN. I'm just trying to correlate to you. We'll try to understand what is meant by a software layer. We'll try to understand what do you mean by a hardware layer through this example. Now what happens once the session has started? Order goes to the restaurant. So order is being prepared. So this is where till this point, if you see till this point, there was no person involved exactly. I mean, except for you initiating the session, everything happened on the application only. Everything happened on the application level only. No human was involved in this, except for me placing the order. Everything was happening at the application level only. On the computer only, everything is happening. If you see from here to here, this is all done by the humans only. I mean, some person does it. Order is being prepared. Order is being collected. Now the delivery boy and vehicle, these are the lower level layers, right? These are the one who are delivering the content to me, and customer collects the order. So in this whole layer, people are involved. That becomes the hardware. I mean, these are the people who are actually getting the things done. At this level, the application is doing the work. So whatever things we are looking at, this food delivery service, it can be divided into two aspects. One where things happen at the application level, where you open the application, you place the order goes to the restaurant. From there onwards, it is all till the time it gets delivered to you. The person, I mean the delivery boy and everyone comes into the picture. So that is more like a hardware layer. Now, in this context, what might happen is, let's say order went to the restaurant. The same person might prepare the order and same person might deliver the order also. So in that context, it might be possible that these two functionalities may be integrated into one common layer itself. There is a chance that the same person prepares the food and same person delivers the food also. So it is possible that whatever data link layer is there, whatever network layer is there, they both can be merged into the same functionality. It's all possible. So that is where my OSI reference model gives me flexibility to update these things to some extent. I can't say that I will do application here, I can't do data link layer here, but to some extent I can change the functionality. Once the item has been delivered to you, the session gets closed. Session is closed. And application at restaurant closes the order. See, even at restaurant level, they know that item has been delivered. For them, that session has completed. Now, if you look at a bigger picture, what is happening is there are two people involved here. One is the customer who is opening application, who is presenting, and he's creating a session. There is a session getting created. Then there is a transport network, data link layer. Then there is a physical layer. So why this diagram is important for us is, if you see, in this case, what happens is, when I have opened the application, whatever I have opened application, I place the order. That same there is a dotted connection happening between this application layer and the restaurant application layer. Understand the point. The dotted connection means my whatever I opened application, he will also have a similar Swiggy application. When I come to the presentation, when I create one order and place the order, okay, for him also similar thing will be there, where he will see how the orders are being represented. When I start a session, like my order got placed and session got started, for him also one session got started. So there is a dotted connection that happens between each layer. So that means as a node, see, understand the term node. As a node, even I have all these layers running in me, with me. Even the restaurant has these layers running in it. Some of these layers are done at the computer level or at the software level, where, see, here no human is involved, actually speaking, to all this. Whereas from here onwards, human intervention comes into picture. Okay, now here, and finally what happens? The food is prepared and it is being delivered to you through different medium. Now here what might happen is, as you see, that food delivery can happen through various modes. Right now, what is the mode they use? They use bike. It might happen that instead of bike, they might use drones. Instead of that, they might use car. Everything is possible. This is where one of them is like using Mac, Ethernet Mac. One of them is like using Bluetooth. One of them is like using Wi-Fi. There are different ways the connection can be established between one component and another component. But essentially, inside that component, this layering is similar. Layering is similar, and all these layers are further divided into two parts, one being called as software related layers, one being called as hardware related layers. Now let us understand what is the difference between the software layer and what is meant by hardware layer. Can someone tell me how do we differentiate between hardware layer and software layer? What is hardware layer? What is software layer? And we were talking about the connection between two components can be either through Ethernet LAN protocol, Ethernet protocol. It's a LAN protocol. Okay, that connection is what we call as LAN, local area network, or it can be through Wi-Fi. See, me and in my house there are, let's say, 5 laptops. We all can be connected through Wi-Fi. So what is that I can do with Wi-Fi connection? I can copy some files from another laptop to my laptop. In that, LAN is not coming into picture. Is Ethernet coming into the picture in that whole scenario? Can someone tell me? Let's say there is, in my house, there are 5 laptops are there. In one room, one laptop, another room, another laptop. Like, let's say 5 laptops are there. I'm using the Wi-Fi. I'm copying some file from one of the laptop. It is possible. I mean, if you are aware of this, how these systems can be interconnected, it is possible. Now, can we call this as LAN? Can I call it as LAN? No, right? It is not called as a LAN. So LAN would specifically refer to the ecosystem where Ethernet is involved. Ethernet protocol is involved. It could have been connected through Wi-Fi, and you can do the same thing, same transfers to the Bluetooth. Now, based on various parameters, the different people may use different things. Like someone may use Ethernet protocol because it is a cheap, I mean, it is a cost-effective way of interconnecting the things. See, for Wi-Fi, it requires its own cost, right? I mean, for Wi-Fi, what do you require? You will require the Wi-Fi related Wi-Fi logic to be implemented. Probably that is more costly than Ethernet protocol, and you need something to transmit and receive, right? That again might be a costly thing. And Ethernet is uses digital protocol. I think it uses digital communication protocol, that makes it cheaper. I mean, there might be some advantages. There are advantages why people use Ethernet protocol for local area network. Now, let us come back and understand how hardware layer and software layer differs. Can someone tell me what is your understanding about hardware layer and software layer? What is the difference when we say this application layer happens in software layer, presentation happens in software layer, session layer happens in software, and these layers happen in hardware? What do we mean by that?
So the software layers are the ways of interacting with the end user.
Software layers are the end user. Okay. Any other definitions? How we can differentiate software layer and hardware layer?
So whatever the functionality we handled in the code written in software, that will be the software layer. Hardware involves the chip, gates, logics.
Yeah. So basically, how we can differentiate these two things is application is something. A software layer is something that is implemented as a set of drivers, which is loaded into memory, and microcontroller or processor fetches these instructions, fetches this application, and runs the instructions present in this application. That is software layer. Now, what is hardware layer? Finally, these application needs to be executed, right? These applications needs these instructions require a hardware which will execute these things, to hardware to execute them. That becomes the hardware layer. Let us try to understand through an example what can be a software layer. Let's take one practical example to understand in networking terminology only what can be an software layer. Okay, yeah, I think it's easy to understand now. Let's say we have a college campus where hundreds of systems are connected using LAN, right? It is possible, right? In that case, since all of us are connected, and you know that each of us will have some unique connection numbers. Let's say 120.100.10.1, something like that. Let's say some IP numbers are there, a series of IP numbers. I'm not sure whether this numbering is correct, because 120.100, I'm not sure what is the meaning of exactly these things. I just took a random number. So let us say a system of IP address equal to 120.100.10.15 wants to copy a movie file from IP of 120.100.10.95. It is possible. This is one system, this is another system. So what I would do is, first I would open the right, somewhere if you go here, you will be able to check what all systems are connected. I mean, there will be one application where you will be able to see what all systems are connected in the network. I mean, we open the application where we see what all IPs are available, IPs are connected in system. We invoke a application request to copy a file from the destination laptop, destination system, or in this case we'll call it as destination node. And this application, this request is being generated at application and presentation layers. See, that is where all these three layers are coming into picture. See, when you went to the my computer, and there it will show you what all IPs are there. You went to specific IP, then you invoked, you initiated a transfer, you started, you copied it, you right clicked it, and you copied and pasted it, you pasted it. All that is happening at these layers. In that, if you see, you may say, where is software coming into picture? See, the concept of you right clicking and opening, copying and pasting, it is creating this request is essentially a series of Ethernet frame transfer requests. At bigger level, at bigger level, at application layer level and presentation layer level, at bigger level, that is at application and presentation layer level, this is a packet. I mean, you are requesting for some packet transfers. That packet transfers goes to the session layer. Whatever you requested for packet transfer, that goes to the session layer. This session layer sets up a transfer session, where transfer session means what? The file file data is being transferred to your system. Then once it is transferred, who is actually doing the work? This file data is being framed by the data link layer. Actually, if you talk of Mac, this network layer won't be there. I mean, the whole functionality will be implemented by the data link layer itself. So this probably won't come into the picture. My data link layer of destination laptop, the data link layer, DLL of this is essentially we are calling as the Mac portion, okay, of the destination laptop, sets up and creates Ethernet frames using the above session request. Understand the point. The destination laptop by itself doesn't do anything. It got a request at top level that this laptop is requesting for some data from me. What is the data? Where is the data is present? It is present in somewhere in my hard disk. In destination laptop, somewhere that data is present, right? See, destination laptop has a hard disk. Somewhere the file is present. How does it know that? This data need to be collected from this location only? How does this laptop know? That is something I have created as part of the session. When I created a session, it in turn what I'm not sure whether I'm confusing you with too many things. Here what is happening is the session that we created. What is the session? Transferring of whole movie file to my laptop. That is the session. To my laptop is the session. In this context, what this session will do is, this is still understand, this is still at software level. My destination laptop, the destination laptop processor, inside destination laptop, one processor is there. Let's say Intel i5 processor is there. Assume Intel i5 processor is there. What it will do is, it will program based on above session created. It knows where the movie file is present in my laptop. My laptop means what? Destination laptop. My means what? Destination laptop. So what it does is, based on the above session created, it knows where the movie file is present inside my laptop. It programs the Ethernet MAC registers. This is the very critical point where the handover is happening. You understand? Handover is happening from software to hardware layer. What happened? I have created a session. Where it all started? It all started from here. It went through the physical layer. The request has reached to the top layers. That my request is what? I want to read some data in your laptop. In your laptop, somewhere in your hard disk, one movie file is there. I want to read that laptop. When that request came, my data link layer and physical layer don't understand all that information. See, when I am sending it, it won't understand anything at all. That request is generated at the application layer. That request has to go to the application layer of my destination. In between layers won't understand, because whatever I talk at this level, only this guy can understand it. And whatever I talk at presentation layer, only presentation layer can understand it. Right now, whatever I generated at application layer, what is that I wanted to do? I wanted to read some data from laptop. So whatever three layers are there, application, presentation, and session layer in my system, my laptop, that is the laptop on which I am working on, it created some packets out of it. It generates a request that it will further tell to the hardware layers that you need to send this kind of packet to the destination. So this, my laptop hardware, that is the hardware layers, data link layer, network layer, and physical layers, collectively creates some Ethernet frames, which goes here. And finally, that information reaches to the application layer, where application layer understands that, see, the source component is requesting me to send the data. As part of the packets that it received, as part of the information it received, it knows what is the data I am requesting for. So what it will do is, it will further create one session which will program the registers in my Ethernet MAC. Inside my Ethernet MAC, some registers will be there. What we will going forward, what we will call them is called as descriptors. There will be something called as descriptors. These registers I'm telling, right? These registers are called as descriptors. Transmit descriptors and receive descriptors. So what is happening here? In my laptop, Intel i5 processor is there. On that, some LAN related application is running. So the LAN specific application, presentation and session layers, ends up, they will result in configuration of the Ethernet MAC registers, which are called as transmit descriptors and receive descriptors. So once configured, once these registers are configured, the overall work is now with hardware. It's like telling in the food delivery example, once the order is placed in the delivery boy hands, this application, everything is not into the picture now. It is all with the hands of delivery boy, how he comes in vehicle and how he hands over it. That is all what is being done at this place. See, it again comes down to how he is going to pack, how this guy is going to pack, how the data layer is going to pack it. Now, there is again a chance that delivery boy may not deliver it to you. He may not even give it to you. See, earlier there were scenarios where delivery boy doesn't deliver, right, for whatever reason. So it may so also happens. In all those cases, this is not into the picture. It is all still need to be. It is happening at hardware layer. For some reason, the packet got dropped. For some reason, error got introduced. In all those cases, it doesn't get delivered. So that issue can be with the hardware. Okay. Now, what hardware will do in this case? Like I told you, order is prepared, order is collected, and it's being delivered. What my hardware layers will do is, in Ethernet MAC, hardware layers will frame the packet, frame the Ethernet frame. I mean, they will develop Ethernet frame using the movie data. I wanted to read the movie data. These descriptors is the one which tells what data to get, from where to get. These descriptors indicate to the Ethernet MAC where the data is present in hard disk. And MAC goes and MAC performs read to this hard disk address or location and gets the packet, gets the data. It gets the data. And MAC DLL, data link layer, you see MAC data link layer, develops an Ethernet frame. Going forward, you will see that that frame is what? Preamble, SFD, startup frame delimiter, destination address, source address, length, payload, and frame checksum sequence. Actually speaking, this payload is the final thing, is the actual food we are getting. Whatever item we got, this is what is the food we are talking about. This is like a checking thing, that is it happening fine or not. I mean, has it reached properly or not, without any spillover or without any problem, has it reached? That is frame checksum sequence. This is telling you how many items have been delivered to you. I mean, you ordered, let's say 3 items, you got only 2 items. Is it correct? No, right? It tells you how many items have been you ordered and have you got those many items. That you can check. Source address will tell you which restaurant you got it. See, it may so happen that you ordered from one restaurant and you got the whole package from different restaurant. Then it is wrong, right? Destination address is like, for the delivery boy, destination address is important because through that only he knows in which direction, where to come. The start of frame delimiter. This will be more like tracking order number. See, the delivery boy may have 10 orders to give you. So he will make sure that he is giving you in the right order. Preamble is like a phone call. See, when delivery boy comes, you don't wait. Let's say I placed order at 8 p.m. For example, I placed order at 8 p.m. I don't go to my gate and wait from 8 p.m. onwards, right? What do I do? Tell me, what do you think I wait for? How do I sync up? Can someone tell me? I get a phone call from the delivery boy that I'm going to reach in 2 minutes. So that is where my synchronization starts. Same way here also, there is something called as preamble, which is indication by the packet that now something is going to start. Now something is going to start. So like that, who is creating this packet? Who is creating this packet? Preamble, SFD, DA, SA, length, everything is, who is developing this packet?
MAC DLL.
MAC DLL is
MAC
DLL. Now, okay, there will be some guidelines which will tell what can be the minimum size. Like payload can be anywhere between 42 to 1500 bytes. Okay, why is it important? It is possible that you may order for one coffee, only one coffee. It is not delivered generally because it's more like just delivering one coffee, we will end up spending 50 rupees in delivery, and this item cost itself is 10 rupees. So rather they won't deliver that itself. That is where some minimum size will be there, some maximum size will be there. The payload size should be within that limit. See, same thing, you may ask him to deliver 1000 items, which is not possible, right? They will have some limitation on what is that one person can deliver. See, one delivery boy can only deliver specific number of items only. That is where they have come up with some range called as 42 is the minimum length, 1500 is the maximum length. These numbers 42 and 1500 is in terms of octet. What does octet stand for? So octet refers to 8 bits of data. Okay, 8 bits, it's not 8 bytes. Okay, so I hope you understood where the software is coming into the picture, where hardware is coming into the picture. My laptop itself can be divided into two parts. One where laptop itself can be divided into two parts. One is the OSI specific, OSI software specific layers. Okay, this is no hardware. This is there is it is, you cannot visualize it like a hardware. You cannot visualize it like a hardware. See, if I ask you to visualize USB port, you can visualize. See, this is laptop. There is a 4-pin port is there, that like that you can visualize. But software layers cannot be visualized. Then what is software layer means? I mean, if you can't visualize it, what is it? Basically, these are set of drivers. Set of drivers. Again, what is drivers? Some binary code which is loaded into some memory. I have already told you, I think that's all what we have already listed. This software layer understands, this software layer gets requests from other node software layers. I told you, right? When I wanted to read from this laptop, my software layer, my laptop software layer, I went here, I went to my system, somewhere I clicked it, right clicked, then I went to the system, there from there I said copy a file. I went to one specific laptop in my LAN network, I said copy. That is all where this is coming to picture. Software drivers, everything coming into picture. Finally, between, understand, this is very important point, between software layer, how the software to software, how software layer to hardware layer handover happens. Can someone tell me? We have already discussed the same concept. How does that handover happens? That activity handover. Now software layer needs to tell hardware layer that you have to do this work. You have to go from here. You have to go read the data from this part of my hard disk and create a packet of this much size and start transmitting this many packets. How does software layer tells that?
By configuring the registers.
By programming registers. By programming descriptor registers. Then what happens is these frames reaches the source laptop. I mean the one which is requesting. It again goes through the reverse process. It goes through exact reverse process. What is meant by exact reverse process here? Once it reaches, let's say in this case, assume that it has reached here. The Ethernet frame has reached here. What physical layer will do is it will check whether the frame has reached properly. I mean, it will check whether all the bits are proper or not. Then it will reach here. It will check whether the individual items have come properly or not. I mean, is there any problem with the packet? Is there no, I mean, let's say we are talking about food item being delivered. Is there any break? I mean, is there anything that got spilled over or anything? It will check that. Then what data link layer will do is, in the reverse side, it will write it into my hardware, my laptop hardware. How does it know in my hard disk which part of hard disk I need to write? How does it know that? Again, I would have configured my data link layer with that information also. I would have told to my MAC layer that whenever some frame comes from this specific address, you store it into this address. That is something, again, I would have informed. So the hardware works as per the software instructions. Understand, the essence of this is what? Hardware layer is completely dumb. Hardware layer is completely dumb. It cannot do anything of its own thing. It cannot do anything by its own. Every instruction has to come from the software layer only. So that interfacing between software layer and hardware layer happens through software layer using the processor. In this case, let's say Intel i5 processor, Intel i7 processor, whatever is there. It uses that, and it has got a series of instructions which these processors execute and programs into my hardware layer registers. Through that, the software layer is telling me what I should be doing. For example, I have to frame a packet and send it, it'll tell me that. For example, if I have to get a packet and store it into memory, this will only tell. So processor is the one. Again, if you ask me, processor is also a hardware. Processor itself is a hardware, right? So it is the software layer which is telling to the processor that you do this work. So this is the essence of what is software layer and what is hardware layer. So do you have any questions till this point? Now, while doing all these connections, there will be various parameters comes into picture. Do you want to send the packet only to one device, or do you want to send it to multiple devices, or is it a simplex connection, or is it a full duplex connection? All those things come into picture. So someone is asking, what is transport layer doing? So we will discuss those things as we go forward in the individual slides. Now, while during this food delivery service, the things can go wrong at many places, right? The application itself can go wrong. The order doesn't get placed. The issue can happen with the delivery boy. Same way, the issues can happen at various layers. The application issues can happen at the wrong software being loaded. I mean, the software layers not being configured properly. Issues can happen with the hardware layer being not working properly. So at every stage, there will be some mechanism to check whether things are happening properly or not. Mostly in the hardware layer, it happens through the something called as checksum sequence, that is frame checksum sequence, also called as CRC checks. Through that, we figure out whether the packet is getting transmitted properly or not. All those things will be checked. Now, when it comes to the application layer, it's a different level of check. I mean, as a verification engineer, as a hardware engineer, we don't really worry too much about these layers. Now, if you ask me, I'm a verification engineer, I'm a Mac design engineer working at hardware level, what is that I should be focusing on? You should only be focusing on these aspects. That's all. These things are really of not much of importance for us, because all the hardware, whatever we say, Mac, registers, descriptors, everything we are talking about, framing, developing the packet frame, and getting the frame, understanding the frame, everything happens at this time. Let us take a break here. We will meet in 15 minutes, then we'll continue with the further topics.
This conference will now be recorded.
So till break, we were discussing about the various layers in OSI reference model. I have told you that OSI is just a reference model which tells how the various aspects of network device can be organized into two parts, software layer and hardware layer. it does provide with the flexibility where user can update individual layer functionality as per their specific requirements. On top of all this, IEEE has a standard which tells what need to be done in what layers. So collectively, OS and IEEE standard gives the finer details about what to do in physical layer, what to do in data link layer, what to be done in other layers. For example, as I said, most of all the Ethernet MAC related functionality gets implemented into data link layer and physical layer. So collectively, these two layers is what we are calling as the Ethernet MAC. Then, now what we will do is, so I have already told you the food delivery service can be through various things. The same way, that is where the LAN connection might fit into picture, Wi-Fi, Bluetooth, different things. Each of them comes with its own advantages and its own drawbacks also. Same way, LAN may have some advantages over Wi-Fi, and Wi-Fi may have some advantages over LAN in terms of the cost, in terms of the performance, in terms of the power consumption. So based on all those parameters, we decide what medium to use for communication. But irrespective of all that, all of them will have the common kind of layering is what you see here. Next. Now let us get into individual layers, understand what is done in each layer. Now when we go through all these slides, you will see each layer, around 7 layers we'll talk about here. And on the left hand side, you will see a top level description of what it does. So these things is what a physical layer will be responsible for. And this is the description of all those features supported by the layer. In this case, the physical layer is the representation of the bits. Basically, one of the features of physical layer is what? Representation of the bit. Data in this layer consists of stream of bits. Now the question comes, whether stream of bits need to be transmitted in analog format or in digital format is decided by physical layer. When you want to transmit in analog format, that will be called as broadband. When it is in digital, it becomes baseband. So there are such conventions are there. Are you using baseband? Are you using broadband? For the LAN, it will be baseband is what is generally used. So the representation of the bits, how the data in this layer, how do we transmit the data in terms of bits, and what data rate to transmit it? See, can you tell me what all Ethernet Wi-Fi, Ethernet max speeds are you aware of? Ten, 100,000. So different standards are there, right? Okay, this layer defines the rate of transmission, which is the number of bits per second. This is important because finally it is the physical layer needs to implement a hardware which is responsible for doing those bit transitions on the LAN cable and transmitting it. When the packet is coming, when the information is coming, is it responsible for capturing all those transitions? So my hardware need to be capable of supporting that data rate requirement. So that is all comes under physical layer. Synchronization. What is meant by synchronization? You need to know that when the data is coming, see right now one laptop is there, another laptop is there. Let's say both of them are connected through LAN cable. Assume that they are connected through the LAN cable, and I'm not doing anything. So should it be synchronizing it? Should it be collecting any data when there is idle phase? No, right? It should not be collecting any information. That is where comes the concept of synchronization, where they understand how do I know that when a packet is coming into me. So in this case, one of the ways it can be is through preamble. There's something called as preamble. It's a series of 56 bits, stream of 56 bits, which tells to the target device that some packet is going to start. So that can be the synchronization mechanism. It is going to start. Now, why we are placing under physical layer is, if you go back to the example of food delivery service. If you go back to the example of food delivery service, it is the delivery boy who calls you. He calls to your mobile saying that I have reached. A restaurant person doesn't call you, right? Restaurant owner doesn't call you that he is going to reach now and he is going to give you. It is this person. So essentially, he is the physical layer for us, and he is the one who is going to inform you that I have reached. So that level of communication has to happen at the physical layer only. So it is synchronization. So it deals with the synchronization of the transmitter and receiver. The sender and receiver are synchronized at the bit level. What the synchronization involves is you should be able to capture the bits properly. See, we are talking about a very high speeds, 10 gigabits per second. Let's say if we talk gigabits per second, it's a very high speed. In a second, we are talking about almost 100 crore toggles per second. So at that speed, it requires some specialized hardware which is implemented into the physical layer to work at that rates, to collect the data at that rates, to transmit the data at that rates. Next feature of physical layer is the interface. The physical layer defines the transmission interface between devices and the transmission medium. How the transmission is going to happen, what all components will be involved, is what is defined as part of physical layer. Then line configuration. This layer connects devices with the medium, that is point-to-point configuration and multi-point configuration. Topologies. Devices must be connected using following topologies. Either you connect through a mesh topology. There are 4 topologies are there. I mean, let's say there is 10 systems are there, 10 laptops are there. They could all be connected through various topologies. One is star topology. I think star topology would be like this. I'll tell you. You have a main system, another router, and further systems. This becomes a star topology. There will be some mesh topology will be there. Mesh means probably everything is interconnected as a mesh. That might be the one. Ring topology might be they are one-to-one connected probably as a ring manner. And bus topology is something where everything is connected to a common bus. This becomes a bus topology. So there are topology means what are the different ways in which all these systems are interconnected with each other. That becomes the topology. Then have transmission modes. The physical layer defines the direction of the transmission between two devices. The physical layer is the one which will define how it is going to happen. Are we going to transmit in simplex mode or half duplex mode or full duplex mode? We will talk more about these things as we go forward. Then transmission deals with the transmission of data, deals with whether to do a baseband level transmission or broadband level transmission. So even though we are studying all these things, when we do the Ethernet MAC, we won't be working on all these things as well, because the MAC itself can be divided into 2 subparts. One is the logical part. The MAC itself can be divided into 2 aspects. One is the logical layer. One is the physical layer. Technically, I'm not sure what is it called as. This is where all the core functionality is implemented. That is framing of the packet, receiving the packet, receiving the frames, and understanding the descriptors. Everything happens here. This physical layer is where all these things will happen into. These concepts are happening to physical layer. And when we say MAC, we are mostly talking about, when we say I'm going to do MAC functional verification, I'm mostly targeting the logical layer verification. So hence, whatever we study about physical layer, it is mostly for academic purpose. What do we mean by academic purposes? Is to get a bigger picture of how MAC works, but these concepts are not going to be something you are going to verify. Next, let us talk about, see here I talked about, when we talked about transmission, we talked about something called as baseband, we talked about something called as broadband transmission. Let's understand what is meant by baseband transmission, what is meant by broadband transmission. Baseband transmission means data is sent as digital signals through the media as a single channel that uses entire bandwidth of the media. See, whatever LAN connection you have, let's say one laptop to another laptop, when we say we are doing it through baseband communication, it is the channel, entire channel is being used only for doing one set of transfer only. At any point of time, only one set of transfer is happening. It is because of the digital signal being used. Now with digital signal, we can't do any kind of modulations. See, we can't do any modulations. Tell me where can we do modulations? When we say frequency modulation or amplitude modulation, what are the type of signals where we can do all that modulations? Please do correct me if I'm going wrong anywhere, because it's been some time where I have studied. So it's the analog is where we can do all the types of modulations. So what is the concept of modulation? I mean, what is the benefit of modulation? Can you tell me? Can someone tell me why are we doing all that modulation? Can someone tell me?
To make the signal propagate for longer distance without changing the qualities, reducing the qualities.
Yeah, that is one thing. What is the second reason? By through the means of modulation, we will be able to use the same channel to transmit more things. I mean, more messages. See, broadband sends information in the form of analog signal. Baseband sends the things into digital signals. Okay, each transmission is assigned to a portion of the bandwidth. Hence, multiple transmissions are possible at the same time. And as per me, this is not possible with baseband. This multiple transmissions is not possible with baseband. Broadband communication is unidirectional. So in order to send and receive, two pathways are needed. When it comes to baseband, data is sent in digital signals through the media as a single channel that uses entire bandwidth of the media. So when we say digital signal, what is that we are talking about? We are talking about something called as, I think you might have heard of something called as Manchester encoding, right? Manchester encoding you would have studied, where 0 is modeled as 1 to 0 transition, 1 is modeled as 0 to 1 transition in that Manchester encoding, and they will send in terms of ones and zeros actually, the data. In broadband, it's not ones and zeros, it is the analog signal which is being transmitted. The baseband communication is bidirectional, which means the same channel can be used to send and receive the signal. LAN is the best example, right? I mean, you can use the same medium to transmit the data and to receive the data. In baseband, frequency division multiplexing is not possible because it's all sent as a digital signals. Ethernet uses baseband for LAN purpose. For LAN connections, whatever you see, when you say you're using LAN cable to do something, it's all through baseband only it's happening. It's a digital signal which are getting transmitted from one point to the other point. That's what. I mean, if you ask me what is that I have to take out from this slide, it is the digital signal is what is going from your laptop to other laptop. It's not in terms of the analog signals. So when I'm talking about LAN, my physical layer need to implement the everything in terms of ones and zeros, not in terms of the analog signals. Now, so this is about physical layer. Now let us talk about data link layer, and this is the most important thing for us, because this is all what we are going to study as part of our Ethernet MAC design. So understanding this will give you a good idea about what are the Ethernet MAC features are about. So in data link layer, first thing it does is framing, then physical addressing, then it does flow control, then error control, then access control. Let us talk about what is meant by framing. The frames are the streams of bits received from network layer into manageable data units. See, frames are the streams of bits received from network layer, and from the top level we get the data. See, you know, network layer is above the data link layer, right? It receives the data from the upper layer in terms of into manageable units. This division of stream of bits is done by data link layer. See, it gets lot of data. See, my Mac reads some data from my hard disk. It is getting, let's say, 1 kilobyte of data or 10 kilobytes of data. Let's assume it is getting 10 kilobytes of data. So it is the data link layer which is responsible for creating Ethernet frames out of this 10 kilobytes of data. So that is what we are talking about. Even though here network layer is not exactly involved, it's kind of a hypothetical layer we are talking about. An imaginary layer we are talking about. It's the upper layers which gives the software layers which gives the data to it. Next, physical addressing. The data link layer adds a header to the frame. A header to the frame in order to define physical address of the sender and the receiver of the frame if the frames are to be distributed to different systems on the network. So what else data link layer does? From here to here, if you see, my Mac, Ethernet Mac, only got the actual content, actual payload. It only got payload. What is my Mac is doing further? It is doing the physical addressing. What is meant by physical addressing? It is adding the headers. What we mean by headers is, it is adding no, not preamble. It is adding start of frame delimiter, source, destination address, source address, length, then frame checksum sequence. Everything it is adding. That is what we mean by physical addressing. Then what else it does? Flow control. What is flow control means? Flow control mechanism for frames to be sent. Can someone tell me what is meant by flow control? What do you understand from the term flow control? Flow control ensures that flow control refers to a concept where, see, if you have to divide the same word, controlling of the flow. What is meant by controlling of the flow? Means, if I will give you one simple example, analogy again. Now we placed the order and one delivery boy is on the way. Is it possible to ask him to, can we make him deliver another packet, another parcel while he is coming to my place, while he is in other work? It is not possible, right? So he has to complete. Basically, it decides, flow control is a mechanism which decides various aspects like I am sending the frame, whether the receiving side has the space to store the information, space to accommodate whatever I'm sending. Okay. Now, if whatever I sent, is it received properly? Is it received properly? If not received properly, I think that will come under error control. Actually, I'm telling everything mix of flow control and error control. See, this received properly is not my job. Actually, it's not part of flow control job. It will be part of error control job. It will be part of error control job. What is error control? Whatever I have sent, is it received properly? Okay, if not received properly, what to do? Means what to do? Should I resend? Should I drop the packet? Various things can be there. I mean, various aspects in which it wants to deal with it. These concepts is what are taken care by data link layer. Now, it might so happen that same data link layer is there in PCI Express also. Similar concept, link layer is there in USB also. Same data link layer is there in Ethernet MAC also. In all the concepts, in all these devices, you will come across the term called as flow control. You will come across the term called as error control also. Each protocol, PCI Express may define flow control as per its own standards. USB may define as per its own protocol requirements, and Mac will have its own requirement. So, but essence of what is essence of flow control? Does the receiving device has enough space to accommodate whatever I'm going to send? Okay, first thing, does the receiving device has enough space to accommodate whatever packets I'm sending, whatever frames I'm sending? Means what might so happen? I may send the frames, but the receiving device is not processing as quickly as I'm sending. So it may result in losing of the packet. It is done so that we don't lose the packets. We don't lose the packets in transmission packets. Okay. It is about buffer management. It is about buffer management, buffer space management. Buffer space means what? Place where packets are stored, where packet information is stored. Buffer space management. So when we get into Ethernet MAC, we'll talk more about flow control, how flow control happens in the Ethernet MAC. The flow control mechanism for frames to be sent. Okay. Now, what else can be the flow control part of it? What else can be the flow control? Giving proper numbering, giving proper numbering to the packets. Okay, all those things can essentially be part of it, and it can also involve exchanging of information on how much buffer space is available. I'm giving very generic overview. Okay, I'm not talking from an Ethernet MAC perspective. It is all about flow control. Is all about controlling the flow. What does it mean? I'm rewording the same thing, but what does it mean? Does the receiving device has enough space when I want to send the MAC frame, but does receiving device has enough buffer space to accommodate whatever I'm going to send? How much space does it have? So it will get all that measure. That is what is flow control refers to. Then comes the error control. What is error control? As it tells you, whatever I sent, is it received properly? Okay. If not received properly, what to do? Should I resend? How do I drop the packet? Should I drop the packet? If received properly, what to do? If received properly, what to do? I mean, generally, what will you do? It is marked as a success. Marked as a success, right? But what to do? There might be more finer details you will get when you read through the spec. You'll get more finer details about how flow control happens, how error control happens. Why these things are important for you and for everyone is when you study any protocol, let's say you study PCI Express, you study USB, you study MAC, or you study UFS or SATA. Anything that is based on OSI reference model, will invariably have a data link layer or a link layer, which will be kind of responsible for these things. These concepts, what you study for flow control, they don't change much. There will be a lot of similarities. Flow control would mean same thing in USB also, would mean same thing in Mac also, would mean same thing on PCI Express also. So if you understand these concepts as a top level concepts, so for you learning any of these protocols becomes a lot easier. Okay. So now let's talk about what is error control. So error control is achieved by adding a trailer. So first, how do we enable error controlling? So it is by adding a trailer at the end of the frame. So the duplication of frames also prevented by using this mechanism. Data link layer adds mechanism to prevent duplication of the frame. So it is one thing is duplication of the frames, and if error happens, how to deal with that. That whole thing will be managed through this. Next, access control. The protocols of this layer determine which of the device has control over the link at any given time when two or more devices are connected to the same link. See, what is access control refers to is, you see, when we talk about different modes of transmission. One is simplex mode of transmission. One is half duplex. One is full duplex. So based on that mode, let's say simplex means what? You can either be transmitting or you can either be receiving the data. Both the directions of data transfer is not possible. So in that context where multiple devices are connected to the bus. So how do we make sure that one communication between one device and other device is established and there is no other device being granted the bus? That kind of things will be controlled through the access control. So protocols of this layer determine which of the devices have control over the link at any given time when two or more devices are connected to the same link. So data link layer decides that part of it. Next, the network layer. I think from Mac perspective, whatever we have to implement in Mac, most of it is part of these things only. Now let us talk about network layer. So the main aim of network layer is to deliver packets from source to destination across multiple links. So there are multiple networks. It is to make sure that the packets are delivered from source to destination across those networks. If two computer systems are connected to the same link, then there is no need for network layer. If it routes the signals through different channels to the other end and acts as a network controller. Basically, it's a connection of various LANs. Multiple LANs being connected is what requires network layer. It also divides the outgoing messages into packets to assemble incoming packets into messages for higher level. See, what it does is when you need to send outgoing messages, it divides those outgoing messages into smaller packets, and when the information comes, it merges all those incoming packets into combined messages for giving it to the higher layers. Transport layer. Someone asked about transport layer. This is where we talk about transport layer. See, the transport layer breaks the message into small units so that they are handled more efficiently by the network layer and ensures that message arrives in order by checking error and flow control. Service point addressing. One of the features is service point addressing. The transport layer header includes service point address, which is port address. This layer gets the message to the correct process on the computer, unlike network layer, which gets each packet into the correct computer. This transport header includes service point address, which is the port address. This layer gets the message to the, and we need to understand, we need to go a little deep into it to understand what exactly does it mean. This layer gets the message to the correct process on the computer. It is providing message to the correct process. It is further routing the, see, I may be initiating multiple requests. It is making sure that whatever packet I'm getting, whatever packet is coming, it is routing it to the correct process on the computer. Unlike network layer, which gets each packet into the correct computer, it further divides that whatever information I got into multiple processes. Whichever process has requested, accordingly it delivers that packet into those things. So the way I can understand here is, where we can understand this transport layer is, if I have opened my browser and I have opened 4 websites parallel and I am playing some information. So through the same LAN cable, all these 4 informations are coming. So the network layer is responsible for collecting all the information related to each of them, and transport layer is responsible for routing it into this one, routing it into this one, routing it into this one, and routing it into this one. That is what I can understand from here. Because parallelly, right? See, I can just go and refresh it. All of them will have open parallelly, right? So if it is happening, means all of them are coming. I don't want them to be merged. If whatever is coming for one website, I don't want them to be appearing for other website. If I open Google, it should not open as some other thing. Okay. So transport layer header includes service point address. Okay, that we have gone through. Segmentation and reassembling. Message is divided into segments, and each segment contains sequence number, which enables this layer in reassembling the message. Message is reassembled correctly upon the arrival at the destination and replaces the packets which were lost to transmission. Then connection control. It includes two types of connections. One is connectionless transport layer. One is connection-oriented transport layer. So in connectionless transport layer, there is no need to establish the connection. Whereas in connection-oriented transport layer, we need to send some initial packets to establish the connection. Then only that we can send and transmit the packets. Then at transport layer, it also does the flow control. In this layer, flow control is performed end-to-end. What is meant by end-to-end is, see, point to point and end to end. Let's understand what does it mean. See, if you understand, let's say in the LAN network, this is my laptop. This is a switch, another switch, another laptop. Let's say these are all connected through this manner. I mean, this will be connected to multiple systems. This will be connected to multiple systems. And finally, my idea is to transfer the data from here. There is a movie file. I want to get that movie file into my laptop. The whatever flow control we talked in data link layer is the flow control at this level. Is the flow control at this level. Is the flow control at this level. The transport layer flow control is at this level, from here to here. Between here to here, when they do flow control, whether checking whether do I have enough information, that would be end-to-end flow control. Error control. Error control is performed end-to-end in this layer. Again, end-to-end error control also refers to same thing, to ensure that complete message arrives at the receiving transport layer without any error. Error connection is done through the retransmission. If there is any error, it is corrected through the retransmission of the packet. Next, session layer. Its main aim is to establish and maintain and synchronize the interaction between communicating systems. Session layer manages and synchronizes the conversion between two different applications. Session layer manages, synchronizes the conversation between two different applications. I think we can again establish the same session layer in terms of my LAN, my browser. I have opened a browser. I have created a session where I am fetching the data from some other server. In some other server, some data is present. I am fetching the data through the this thing. Another browser, another tab. They are creating different sessions, and all that is handled through the session layer. Session layer manages and synchronizes the conversation between two different applications. Transfer of data from one destination to another session layer. Streams of data are marked and are resynchronized properly, so that ends of the message are not cut prematurely and data loss is avoided. Dialogue control. This layer allows two systems to start communicating with each other in half duplex or full duplex mode. Next, synchronization. This layer, I mean, we are all talking about what is all the responsibility of the session layer. This layer allows a process to add checkpoints which are considered as the synchronization points into the stream of data. Again, whatever request I am doing, probably there also checkpoints might be there which checks whether whatever information we are getting to the browser is that coming properly or not. So how does that checkpoints add? Example, if the system is sending a file with 800 pages, adding checkpoints at every 50 pages is recommended. This ensures that 50-page unit is successfully received and acknowledged. This is beneficial at the time of crash. If crash happens at page number 110, there is no need to retransmit 1 to 100 pages, because at every 50 units we have added a checkpoint. So only from 100 onwards you have to retransmit. So that is where session layer can do the synchronization. Next, remaining two layers are what? Presentation layer and application layer. So we will talk about these two layers. and we'll just take a brief about the IEEE standard and we'll end the session for today. In presentation layer, the primary goal of this layer is to take care of syntax and semantics of the information exchange between two communicating systems. The presentation layer takes care that the data is sent in such a way that receiver will understand the information, will be able to use the data. I mean, probably it is about sending the data in the requested format. The languages can be different of the two communicating systems. Under this condition, present layer plays the role translator. It is the responsibility of the presentation layer to make sure that whatever is the format in which information has been requested for, it provides the data in the proper format. The translation before being transmitted. So as I told you, role translator we said, right? In translation, before being transmitted, the information in the form of characters and numbers should be changed into bit streams. The presentation layer is responsible for interoperability between encoding methods. As different computers use different encoding methods, it translates data between formats the network requires and the format of the computer. So it is basically translating as per the various encoding mechanisms and as per the the specific component request format. And it also does the encryption. It carries out encryption at the transmitter and decryption at the receiver. See, whenever we say some data is getting encrypted, decrypted, it is being done as part of the presentation layer. And compression. It carries out data compression to reduce the bandwidth of the data to be transmitted. The primary role of data compression is to reduce the number of bits to be transmitted. It is important in transmitting multimedia such as audio, video. So if there is a compression mechanism is being used, the receiving side also should have a corresponding decompression mechanism which makes sure that the data is recovered properly. It is essentially to reduce the data that is being transmitted. So if you see here, we are not talking about what kind of mode to use, whether to do full duplex mode or half duplex mode, all those things. We are more talking about giving the data in a format that receiver is requesting for, and also to make sure that encryption and decryption is implemented, and it is also ensuring that the data is compressed so that the transmission efficiency can be improved. And whatever all these things you see, transport layer, session layer, presentation layer, none of them will be part of the hardware. All these things will be implemented as an application only. This translation and compression, all this will be controlled through the software instructions. I mean, we have an application which will be executed by the processor and which essentially does all these activities. Next, application layer. It is the topmost layer of the OSI model. Manipulation of the data in various ways is done in this layer, which enables user or software to get access to the network. Some services provided by this layer include email, transferring of files. These are all part of application layer. Distributing the results to the user, directory services, network resources, everything. Mail services. This layer provides basis of email for forwarding and storage. And other than that, it can also do network virtual terminal. It allows user to log into a remote host. Application creates software emulation of the terminal at the remote host. The user computer talks to the software terminal, which in turn talks to the host and vice versa. Basically, it helps set up the network virtual terminal. And other than that, some directory services. This layer provides access for global information about various services. And it also takes care of file transfer, access, and management. It is standard mechanism to access files and manages it. User can access files in remote computer and manage it. What I would say is, see, these are all very high level details. From our current topic perspective, it is better we focus most of our understanding into these lower 2-3 layers would be sufficient for us, and probably get a bigger level picture of what transport layer does, session layer does, and presentation layer and application layer does. So what I will do is, in the next session, I will come up with some examples which will help us understand more finer details about what each of these 4 layers does. And as I told you, any networking device you take, essentially all those devices are implemented as these 7 layers. And this networking is further standardized through IEEE, where they have divided this overall network into 6 categories. One is IEEE 802.1, 802.2, .3, .4, .5, .6. So as I said, the MAC, Ethernet MAC we are talking about is through 802.3. So 802.1 relates to the standards related to the network management. 802.2 refers to the general standard for data link layer in the Osi reference model. IEEE layer divides this layer into 2 sublayers. One is the logical link control layer and one is the media access control layer. The media access control layer varies for different network types and is defined by the standards IEEE 802.3 through 802.5. In 802.3 defines the MAC layer for bus networks that use CSMA CD. Okay. 802.4 defines the MAC layer for bus networks that use token passing mechanism. So there are various things. One is CSMA CD used for collision detection, carrier sense, multiple access, and collision detection. Okay. One is token passing mechanism, and one is for token ring networks. So there are different standards that can be used by MAC layers. All of them is 802.3, .4, .5, and 802.6 is used for metropolitan area networks. So we will talk about all these standards in more detail in the next session, and we will also talk about various topologies and the Ethernet network elements, what is meant by data terminal equipment, data communication equipment, and further into more deep into the Ethernet in the next session. So we will stop the session here. Any question before we end the session?
Sir.
Yeah, please tell me.
Yeah, sir, please upload the related course material on the portal, sir.
Okay, sure.
Srinivas,
Hello,
is
sir.
Amit here? One question.
This conference will now be recorded.
All these concepts, data link layer concepts, gets implemented into this hardware. I think some hardware architecture will be there here. We are going to understand this hardware architecture and we will be implementing the complete verification flow for that. So initial 1 week will be more into understanding the Ethernet protocol, this specification, followed by starting off with the verification. I hope it's clear to you.
Sure, definitely, sir. And sir, it would be good if we can get to know the payment session link, some link.
Yeah, I will share all the details. So tomorrow there won't be any session because many of you are from the regular batch, so Sunday will be off. So the session will start on 7th of February. And that will be starting at 10:30 a.m. As I told anyone, if you miss the session, we will provide access to the recorded video of that session, and we can have a backup session for doubt clarification.
Thank you, sir. Thank you.
Revision and doubt clarification.